Hello everyone, this is our web application which we have secured. This is our login page. We log in with using the credentials. Uh, I'll just explain you how the functionalities are working and then later get on all the vulnerabilities we have fixed. Once we log in into the page, we enter to the second page where all the records are being collected. We do it by creating new record. For example, I give title as assignment 2 and also keep the description of 1 2 3 4. And when we create a record for this, we have our assignment to 1 2 3 4 record been selected. uh, Basically here you can edit or delete the file. So you have your update the record functionality XYZ. We can update and we can also delete the function. The next step would be about how we have fixed these vulnerabilities, and for that I will be explaining we have about 5 different vulnerabilities that we have fixed, and for those 5 vulnerabilities I'll be explaining it through the GitHub. Here the 5 different vulnerabilities are divided into different things, starting with how we first would be the CSRF, cross-site request forgery. In the original version, there was no protection at all. An attacker could trick and logged in user into performing unwanted action. I fixed this by implementing a session-based layer CSRF token. A random token is generated for each user session using OSU random, added as a hidden field in every post form and validated on the server side for all state changing operation. Now any request that comes without having a valid token is rejected. Now then the second thing would be insecure direct object references. Here, this allowed any user to edit or delete record belonging to someone else just by changing the record ID in the URL. So we fixed it by adding strict ownership checks in the database queries. Every update or delete now uses functionalities such as where functions and user ID functions, so that allows you to record or modify any record. The dashboard also hides edit and delete buttons for the record that does not belong to the current user. And then there is a bug in bcrypt password handling. The original code sometimes stores hashes as bytes or didn't handle types correctly, which could break password verification. I fixed this by explicitly decoding the hash to UTF-8 when saving into the database and adding safe type check during login. I fixed it by explicitly decoding the hash when saving it into the database and adding safe type checks compared during login. Now passwords are always stored and compared correctly. Registration had weak or no password rule and could crash or duplicate username. So I added minimum 3 length requirement for this. Username at least of 3 characters and password at least of 6 characters. And wrap the insert in try except block to catch SQLite. If the username is already taken, the user now gets a clear flash message instead of an error. And then I also made sure that the admin user is properly identified by username, and the dashboard uses different queries. Normal users see only their own records, while the admin sees everything with owner information, role based. So that, to summarize, I successfully fixed CSRF, IDOR, bcrypt bugs and weak registration, duplicate username crashes and improper admin handling. So this, combined with the visible default admin credentials on the login page, creates a realistic final attack scenario for learning. This is for a learning purpose. These changes show how straightforward fixes can dramatically improve security, and that's the main lesson of the project. Thank you so much.